Lesson 5.2 is about investigating special triangles. We have two special triangles that we're going to look at. The first one is the 45 degree triangle, where you can see here this is 45 degrees. And we're going to find the sine, cosine, and tangent of 45 degrees. And we're given that these two lengths are 1, the two legs of the right triangle. And the hypotenuse we can find out using the Pythagorean theorem. So Pythagorean theorem tells us that c squared equals a squared plus b squared, where c is the hypotenuse, so c is equal to the square root of a squared plus b squared. And our a and b are 1 and 1, each 45 degrees. This is the opposite side, this is the adjacent side, and this is the hypotenuse. So if you want to find sine of 45, sine of any angle is the ratio of the opposite side over hypotenuse, so which will work out to be 1 over root 2, right? Opposite over hypotenuse. Cosine is adjacent side length over hypotenuse length, so that would be 1 over root 2 again. And tangent is the ratio of the opposite fusions here. Sine 45 equals 1 over root 2. Cosine 45 is equal to 1 over root 2. And tangent of 45 is equal to 1. So we have to memorize these three results. The second type of special triangle is the 30-60 triangle, and we're going to find the cosine, sine, and tangent of 60, and similarly the sine, cosine, and tangent of 30 using this triangle. So the hypotenuse of this triangle is 2 units, and this side is 1 unit, and this half is your right angle triangle. We do not know the length of this leg. Let's call it B. What is the length of B? Well, we know that this is the hypotenuse, right? So c squared to us as 1. So we're going to use 2 squared equals 1 squared plus b squared. And we want to find the length of this leg, b. So rearranging, we get b squared equals 2 squared minus 1 squared. And b squared equals 4 minus 1. So b will be equal to the square root of 3. So that gives us the length of this leg. And using those numbers, we're going to find the sine, cosine, and tangent of 60. Okay, so the sine of 60, which is this angle, let's look at this angle. Sine of 60 is opposite side over hypotenuse. So that makes root 3 over 2. Cosine of 60 is adjacent side over hypotenuse. That's 1 over 2. And tangent of 60 is opposite side's length divided by adjacent side's length, root 3 over 1, which is root 3. Okay? To find the sine and cosine of 30, we're not going to consider this 60 anymore. We're going to focus on 30, right? This is the 30-degree angle. And we're going to redefine what is opposite and adjacent now. So with respect to 30, this is the opposite side and this is the adjacent side. Okay, so we have to redefine opposite and adjacent for 30. We can't use the same thing we used for 60 because that was different. So opposite to 30 is 1, adjacent to 30 is root 3, and the hypotenuse, of course, is still root 2. So sine of 30 is opposite over hypotenuse, so it's 1 over 2. Cosine of 30 is adjacent over hypotenuse, so that is root 3 over 2. And tangent of 30 is opposite over adjacent, so it's 1 over root 3. So all these ratios we are going to use in our evaluations for the next set of examples, okay? So we have those ratios, sine, cosine, and tangent of 45, sine, cosine, and tangent of 30, sine, cosine, and tangent of 60. And we're going to use these ratios. We're not going to use our calculators, okay? So the expression is, what would be the exact value? So exact value means don't use your calculator because you have to round to 4 decimal places. We're not going that route. We're going to use this chart to help us evaluate to exact answers. So what is the answer if you wanted to do cos 45 times sine 30 minus cos 30 times tan 45? So cosine 45, we can see from here, is 1 over root 2 multiplied with sine of 30 is 1 over 2 minus cosine of 30 is over here, root 3 over 2 times tan of 45, which is 1. And we're going to simplify this. So this will be, we're going to multiply both numerator and denominator by root 2. for this. So this is the same as root 2 over 2 times 1 over 2 minus root 3 over 2. That way I have all my denominators as 2. And multiply these two as fractions and you get root 2 over 4 minus root 3 over 2. And then, find the common denominator, which is 4, and you get root 2 minus 2 times 2 is 4, so 2 times 3 is 2 root 3. And that is the exact answer for this expression. Okay. We're going to do the same thing now with question B. I'm just going to draw a line to separate it. We have to find the exact answer for cos squared 60 plus tan 30 divided by sine 60. So cos of 60 is 1/2. So square of that, 1/2 squared, plus tan 30 is 1 over root 3 divided by sine of 60, which is root 3 over 2. So in the next step, we're going to simplify this. This is squared, so you get 1 over 4 here. And this is plus, I'm just going to write this as 1 over root 3. I'm going to flip the second times 2 over root 3. Okay, so that is 1 over 4 plus 2 times 1 is 2 divided by root 3 times root 3 is 3. So now I just have to add these fractions. Their common multiple or denominator is 12. 4 times 3 is 12, so 1 times 3 is 3, plus 3 times 4 is 12, so 2 times 4 is 8, and the exact answer is 11 over 12. Okay, so adding up the answers, we're not using our calculators, we have to use these ratios and simplify. Okay, let's try another example. Find the angle theta, which is an angle between 0 and 90, so it's an acute angle. Find the theta if sine of theta is root 3 over 2. So we know now that if we are given the ratio, we just do theta equals sine inverse of root 3 over 2. And which angle gives us root 3 over 2 for sine? It's only this one, 60. Sine of 60 is root 3 over 2, so theta equals 60 degrees. Now, the second example is the secondary ratios. Cosecant of theta is equal to root 2. So we have to bring it down to a primary ratio. Cosecant is the reciprocal of sine. So we can say that 1 over sine theta, which is what cosecant theta is equal to root 2. And if we find the reciprocal on both sides, that would mean sine theta is 1 over root 2. And theta would then be, which angle will give sine theta as 1 over root 2? It is 45 degrees. So theta equals 45 degrees. Okay, so this was A, this is B. I'm going to do C down here. Sine theta divided by cos theta equals to 1. So if you solve this, multiply both sides by cos theta, you get sine theta equals cos theta, right? Or you can think of it as if you're cross multiplying. And so which angle does have both of the sine and the cosine the same answer? Well, it's not this, but it's this. For both the ratios, you have the answer as 1 over root 2 if the angle is 45. So therefore, theta equals 45 degrees. You see how we're using the table to arrive at the answer? We're not using our calculators. And D, through root 3 times secant theta equals 2. So that means secant theta equals 2 divided by root 3. Bringing this side. And because we are going to go with the primary ratio, this is the secant is the opposite of cos. So 1 over cos theta equals 2 over root 3. So if you flip this, you would get that cos theta would be the flipping of the right side, which is root 3 over 2. And which trig ratio has cos theta as root 3 over 2? Well, if you look at our table, it's the 30 degrees. Cos of 30 is root 3 over 2. Therefore, theta equals 30 degrees. Okay? So that brings us to the end of this lesson. We want to practice these questions now.